This is continuing with terminology and aspects about circles. The first thing that we'll do here is notice what a central angle is. The definition of a central angle is really kind of hard to get. You just can't hardly get it from the language. Okay, a central angle is an angle at the center. Okay, a central angle is an angle whose vertex is at the central of the circle. It's actually pretty easy to get. So if that's the center of the circle, and the center of this circle is C, then an angle going out with radii to the sides, let's say that's about a 50-degree angle, we'll say. So then this is a central angle because the vertex of the angle is at the center. So this is the central angle, and it's ACB, named as we normally name angles. An arc, the definition of an arc, is that it's a portion of a circle. So for this particular one, we're going to talk about the arc between point A and point B on the circle. So this blue here is the arc AB. The way we write that is we'll write A, B, the end points of the arc, with a curved line over the top. You'll recall that with a line segment we did a straight line. You can also just write arc AB if you prefer to do that. Now something different about arcs and their measure. The measure of an arc is the central angle. So the measure of this blue arc AB is 50 degrees. We would say the measure of arc AB is 50 degrees. This is a little different than what we're used to with line segments and other geometric figures. The measure of the arc does not mean that it's congruent to another one. If two arcs have the same measure, they do not necessarily, or they are not necessarily congruent. We'll have other things that have to do with that, and we'll talk about that in a bit. How does that come up? Well, the measure of an arc has to do with the angle between them. Here I've got my watch, and it's just almost a 90-degree angle. Let's say it's 180 degrees. So let's say it's 178 or something like that. It makes an angle between the hands. But the thing about clocks is it doesn't matter if it's a little bitty clock like here in my watch, or a big clock like it's on the wall, or a big huge clock like downtown on City Hall at Houston that sometimes work and would have the angle the same. Analog clocks work because they're all got the same angle. Doesn't matter how big it is, we judge the time based on the central angle, the angle at the center. In this case, it's coming up on 180 degrees and it's coming up on 6 o'clock. Couple of things about arcs. We have minor arcs and major arcs. A minor arc is an arc that is less than 180 degrees. It's named with the two endpoints. This is a minor arc. Arc AB, as it's drawn, is a minor arc. We name it by the endpoints. If it's a major arc, one major arc here is everything else. So for example, there is also a major arc which has A and B as its endpoints. And that's it. To distinguish between them, we need to have an extra point. Just like when you usually do an angle, for example, this angle here, ACB. If I say, what is ACB? You're going to say 50 degrees, but we also understand that there is the reflexive angle that's 130 degrees. The default is I'm going to talk about the one that's smaller than 180 degrees, unless I tell you I want the reflexive angle. Similar with the arcs. If I tell you I want the arc AB, I mean the one that's the small one, not the one that goes all the way around the circle, unless I tell you that's what I wanted. And how I would do that is I would need another point to be named. So for example, I could name a point here, That's D. It doesn't matter. You can name any point you want. So I'd have A, D, B is the major arc. So this one would be the arc A, D, B. You must do them in order, but it doesn't matter which order. It can also be B, D, A, and you can choose any points you want to do this. So that's a major arc. And so you might be saying to yourself, she did less than 180, she did more than 180. I wonder what it is if it's exactly 180. 180 degrees arc is a semicircle. What that would look like would be like this. Of course, since it's halfway, the ends are the diameter. So the semicircle then would come around this way. That's the semicircle. Next up, adjacent arcs are arcs that have a common endpoint. They share an endpoint. So for example, in the ones that I just drew here, adjacent arcs would be AB is adjacent to BD. Oh, those aren't the ones I just drew. That's a different picture, but you get the idea. Here's the ones I just drew. Good enough. AB is adjacent to BD. Same deal. Okay? Now let's talk about congruent arcs. Remember I said it's a little bit different than how we deal with it when we deal with measurement of line segments? Definition of congruent arcs. They must have the same measure and they must be from the same or congruent circles. Again, remember that the same measure, the measure of an angle, the measure of an arc is the measure of the central angle. So if we have, let's see, that looks like about a 60-degree angle. We'll pretend it is. And then if I draw another 60-degree angle, about the same. I'll create a bunch of arcs here. I'll go ahead and label them X, Y, and Z, M, N, and O. So let's look for a moment at the arc XY. This one right here that I'm marking in blue. Does the arc XY have the same measure as the arc MN that I'm marking here in green? It does, because recall that the measure of the arc is the central angle. They both have the same central angle of 60 degrees, so they have the same measure. That's an example of the clock here. And the clock's now up to a little bit bigger of an angle. They're 150 degrees, a little bit smaller of an angle. So again, the idea of the clock is it works here real tiny on my wristwatch. On the wall, it's bigger. On City Hall, it's a lot bigger. But you can always tell what the time is by the orientation and the central angle that's on it. That's what we're doing here. This is like a little clock and this is like a big clock. Does it have the same central angle? Yes. Is it the same measure? Yes, the blue and the green. But they're not the same length. This took more green ink than this took blue ink. They are not from the same circle. Okay, congruent circles. When we talk about congruent circles, we're talking about the same radius. Usually when we talk about congruent figures, we talk about size and shape. Well, let's think. Circles. Circles are all the same shape. They are round. Since they're all round, they're all the same shape, then we just look about the measurement of it, the same size. And we usually use the radius as a the method to say if they're the same size. You can use any other ones, the diameter, circumference, or whatever, but basically the radius. So if I have here, what about over here, the one I've just marked in blue again, YZ? Is YZ congruent to XY? Yes, it is. It has the same measure. They are both 60-degree arcs, and they are from the same circle, not just similar, actually the same circle. Same deal here. MN is congruent to NO, but all of four of these angles are the same measure, but they are not congruent. Only the ones in the same circles are, if they were congruent circles, same deal, would be the same. Excuse me, would be congruent. I said that wrong. Okay, here's a nice little postulate that's not going to be a surprise at all. The sum of the parts is the whole. If we add two adjacent arcs, we get the total arc. So these are adjacent arcs. They share a common endpoint. AB and BC are adjacent. Together they make the arc ABC. Some practice. Are the two red arcs congruent? Yes, they are. They're from different circles, but the different circles are the same size because the radius is congruent. The angle measure is the same, which means that the measure of the arc is the same, so these two are congruent. Are these congruent? No, they're not. Although they have the same angle measure, the arc measure is the same. The radius is different. This one is not congruent because it's larger than that one. How about these two red ones? At first you might say no, but when you subtract off, you find out that this is actually a 70-degree angle, so the two red ones are congruent. Are these congruent? They have the same measure, but they do not have from circles that are congruent. There's a larger circle and a smaller. They have the same measure, but they are not congruent. And here endeth the lesson.